Hi everyone, trust you're doing good. Okay, let's go. If this is your first time, I want you to subscribe to our channel, watch our videos, comment, engage. Now, yeah, subscribe. Yeah, now. Good, I got you. Now, differentiate between H2S and SO2. Okay, now this thing is very, very important. It's a very important concept that you have to understand before you even go to that exam. It's very, very important. Okay, now H2S in itself is a reducing agent. SO2 is also a reducing agent. Okay, first of all, take note of that. But just like some of you in your school, you are very smart. You used to reduce everybody. This one will come, you'll be the first position, you just carry first position. That means you are reducing everybody in your secondary school. But when you get to university, you will see that with many reducing agents will come together. Those that are topping in their schools will come together. People that are very good. So you realize that eventually you become an oxidizing agent because that person that is better, way better, will reduce you. That's what is happening. So this is a better reducing agent. It's stronger than this. So in the presence of a stronger reducing agent, SO2 will bow, just like some of you will bow in the presence of someone that is better than you. So what now happens? H2S can react with SO2 to form what? It can give H2O plus S. Now, I'm not teaching readers, but let me just teach you something here. Because all these things are very easy to calculate, to get reducing agents. And don't forget, first rule is that both reducing agent and oxidizing agent must be on the reactant side. First thing to note. So now look at it. This is plus 1. S here is minus 2. X here is what? Is plus 4. Why? Minus 2. You might not see what I'm doing, but it's easy. I'm just calculating the original number of these guys. So to get this, H2S equals to 0, abi? So plus 1 times 2 plus x equals to 0. So s is what? Minus 2. That's why this is minus 2. This is plus 1. This one, same thing. SO2, that's x plus minus 2 times 2 equals to 0. Then s minus 4 equals to 0. Then s equals to plus 4. That's how I got this. Same thing. This is plus 1. This is minus 2. And oxidation state of a free element is what? 0. Now, let me clean this. Hope you understand. Good. I will still teach you redox reaction. No way, when I teach you redox, you will get some things very well. Now, hydrogen here, Abi, plus 1, nothing. You cannot see. S here minus 2 to 0. There's something, there's a relationship. If you go from minus 2 to 0, did you reduce or increase? You increase. Positive numbers are greater than negative. So you increase. So increasing oxidation number means oxidation. Decreasing oxidation number means reduction. That's another way to define oxidation and redox. Okay, because there are ways to define redox. Okay, let me tell you. Reduction, we can define it in 3 ways. One of the ways is that we use what? LOGA. What does LOGA mean? Loss of electron. Look at it. Loss of electron means what? Oxidation. Gain of E electron means what? Reduction. So there is one way to define it. Another way to define it is what? Is that oxidation means addition of oxygen. Oxidation, you oxidize someone. While reduction means what? Removal. Okay, we can say oxidation means addition of oxygen, removal of hydrogen. While reduction means addition of hydrogen, removal of oxygen. That's the second definition. But the third and most important definition of redox, that is reduction and oxidation, is this one. That's why I have to write it down. It's very, very important. Oxidation means increase in oxidation number, while reduction means decrease in oxidation number. See, if you know this one, you can never go wrong. It can never fail you. All this one, addition of oxygen, removal of hydrogen can still fail you. Look at this one. Though this one, it can still help here. Look at this to this. I've removed hydrogen. Abi? So I can say if I remove hydrogen and I did not add oxygen anyways, but I've done one of the two. I've removed hydrogen. And removal of hydrogen is what? Oxidation. So this means this guy is undergoing oxidation. Okay? It's undergoing oxidation. Now look at this. S is plus 4 here. There's no X here, but X is here. Plus 4 to 0, you are reducing the oxidation number. Abi now? So from here to here is what? Reduction. Now, this is the way I used to know it. It's very easy. If you undergo oxidation, you yourself that undergo oxidation, you are a reducing agent. If you undergo reduction, you yourself that undergo reduction, you are an oxidizing agent. You don't pick oxidizing agent and reducing agent from the what? From the product side. Where do you pick it from? From the reactant side. Can you see that? What I just explained. If you ask me SO2, what is it? It's a reducing agent. But in the presence of a very strong reducing agent, it becomes an oxidizing agent. You know, this is very, very important concept. So this is like me giving you an insight towards redox reaction. Okay, because it's very, very, very important. So this explain redox. Take note of that. Another thing that you have to note is that cryo. Another thing you have to note is cryo. What does it mean? Cathode. At the cathode, what happens at the cathode? Reduction. Cathode reduction, anode oxidation.